Hello, everyone. This is Sebastian Traeger, Managing Director at Reliability, and welcome back to another episode of Reliability 4.0. As always, we are on a mission to help make the world a more reliable place. And today we're being joined by Chris Barkow, who's going to talk with us a little bit about his work. Chris is a Reliability Solutions Manager at Regal Rexnord, and specifically in the Perceptive team, which is the reliability team there. And we are thrilled to have him. Chris, thank you for joining us today.
Thanks. Thanks for having me, and happy to be here.
Yeah, great. Well, Chris, just to get started, we'd love to hear a little bit more about the company and your role in it.
Sure. Yeah, so I'm a solutions manager here with our Perceptive group. Our Perceptive group is a reliability solutions group. So my role is really to currently to gather information around customers' needs, build a solution out, and drive them to the appropriate outcomes that they're looking for. That's a general statement on purpose because we have a lot of flexibility within that whole range.
Great. How, at a high level, give me just kind of a little bit of a background of how you became a reliability engineer. What's your kind of origin story?
Yeah, absolutely. This is something I go into often with my role, is to describe my origin story. I'm a mechanical engineer from Purdue University. I have a background in leadership as well. I took some NOLS courses, NOLS, National Outdoor Leadership School.
Yeah, of course.
And then my first job was actually in validation engineering at a major pharmaceutical manufacturer as a contractor. And I got into some PLC programming and troubleshooting there. And I got into document writing and things like that. So I got into kind of the nitty-gritty of how systems operate and to make sure that they are operating correctly. After that, I went into steel mill maintenance. So a big jump. And I started as a reactive maintenance foreman. I got really tired of getting called at 2 a.m. Every week to come out and fix things. And I said, there's got to be something better, right? So I talked to my millwrights out there. I had a team of about 25 millwrights that I led for the 9 years I was at that plant. I never lost my responsibility for them and managing that group, but I did move also into a preventive maintenance role. So I was using software to write preventive maintenance routes, determine the proper inspections and things like that. And I saw a real return on investment there with me getting called less. Part of that was also, redesigning equipment and preventing those failures from happening again, not just discovering them, but also preventing. And as part of that, I got into the capital improvement mode as well, doing some major redesigns and equipment purchasing. So because of that experience, I was pretty focused on working at that one plant. I actually wanted to expand my scope. So I get to work in lots of different industries now as a reliability engineer, and in food and bev, oil and gas, pulp and paper, aggregate, et cetera, and of course, metals. I still focus on metals, and because of my experience there, I got very much into torque monitoring. So I have vibration experience, infrared experience, et cetera. But my focus has been torque monitoring, real-time torque monitoring.
Great. Well, we want to hear a little bit more about that. But before we dive deeper into that, I'm curious. I always like to ask folks one thing they like to do outside of work. Do you still do kind of some of that NOLS outdoor kind of hiking, leadership type stuff?
Yeah. So I'm married. I got 3 kids, and I try to get them out to hike on the trails. I do that as much as I can. They're still pretty young. We'll do more of that as they get older.
Okay.
I also am a avid mountain biker. So I do a lot of that, and I also travel and snowboard as much as I can.
Wow. Where's your favorite place to snowboard?
Well, I just got back from Steamboat, so right now I'm going to say it's Steamboat,
nice.
Colorado. That was incredible.
Yeah, hard to beat that. That's pretty incredible. You keep doing that. Well, let's dive back into work, and because you're working across a number of different industries, this question you might answer either for your company or for what you see. But when you're thinking about sort of KPIs for reliability engineers or for that role, what do you see as maybe the most common KPIs that people are solving for?
Unplanned shutdown time. That's always it. They had a failure. They didn't expect it. It's expensive. And so I end up getting into, okay, how much does your downtime cost you? You know, every time I go to a customer to start solutioning, that's one of the first questions. What was the failure? What do you think caused it? How much did it cost you? And then we can get into what's the appropriate technology to use to measure data and prevent that from happening again. Yeah, it's unplanned downtime and then of course cost avoidance.
So when you're kind of working with different folks and you're looking to say, hey, how can we reduce or eliminate unplanned downtime? You mentioned after you kind of determine what maybe the problem was and what a solution. What do you see as tools that you can bring to bear? What are maybe the most common things that you're typically recommending as possible solutions to make sure that doesn't happen again?
In my role here, I've got a lot of different tools to use, whether it's technological tools or just experience-based tools, because we have some extremely experienced people on the team from services standpoint. So the most common one is, of course, vibration. When it comes to most rotating equipment, we're dealing with vibration, but vibration can't catch everything. So you can add temperature on top of vibration pretty easily. When you talk about vibration, you have to say, do you need continuous data versus use a wireless sensor and get some more intermittent sampled data? So we go into that and see how does the equipment operate. It's all part of the solutioning there. But to cite a recent example, we had a new customer who was still kind of trying out the systems that we had there, wireless systems, approach us and say, hey, we had a coupling failure. And it was kind of a transient type of failure. It was an overload condition. Why didn't our vibration system pick it up? I said, well, vibration's not really gonna catch that type of failure. That was a torsional failure. So let me tell you about our torque monitoring. So torque monitoring and vibration monitoring really work well together. If you have bearing issues, it's going to be, and gearing issues, vibration is a clear strong point. But when it comes down to some other drivetrain issues, whether it's gearing or just overloads on couplings, especially repetitive overloads, they might not fault out the motor on whatever equipment, but they might just go over the fatigue limit a little bit. You'll never see it with your motor current monitoring. You'll see it with torque. So vibration monitoring, excellent tool, of course. Temperature monitoring, but torque monitoring is usually the one that people don't talk about enough.
That's good. So that's kind of like your three legs of the stool to at least be able to anticipate when something might be reaching a failure condition.
Right.
Related to that, because again, I like that you're working with different customers. How do you help them put a business case together? Because I mean, even those three things you mentioned, they might say, okay, I want all three of them, but how do I put a business case in place to justify those investments?
We talk about cost and how much did each event cost you, and it's difficult. That's a tricky question, I know, because most companies want to hear something about ROI, and instead we're talking about cost avoidance. So you have to dig back into history. I like to go 1 or 2 years and say, how many downtime events of this type or from this equipment did you have? What do you have cost associated with that? They usually can come up with something, based on their production rate or something like that. So, for aluminum customer, they didn't have that information, but I was able to kind of back out from some of their public records what that cost could be based on their production, the publicly reported production.
Okay.
And that one was about $200,000 an hour. So
that's what
if we're,
an hour of downtime was costing them, of unplanned downtime.
that's how much revenue they generated per hour,
Oh, I see. Okay.
right? And that's rough, that's just my calculations. But so if we're pitching a system that's going to cost them, say, $20,000, their ROI with 1 hour of planned time that they're saving, the payback is really fast. So putting those
Go
numbers
ahead.
together really helps.
Yeah. So if I say it back to you, you're effectively trying to, one way to do this is to say, what does an hour of runtime make you?
Mhm.
Right. So it's like almost counterintuitive, like just, hey, here's your revenue, divide by hours you run the plant. This is your per hour of revenue. Well, now we know what saving an hour of downtime is what that's worth to you. So if we save you one incident a year, 4 hours, in that example you gave, that's $80,000 we can save you with this condition monitoring or vibration monitoring, et cetera.
Right. Yep.
It's good.
It's
I like
pretty
that.
straightforward when you look at it like that. But it's hard to justify it's hard for end users to justify it to their management. That's usually how it goes. Pitch, talk about the ROI, and then they need to sell it up to get that money allocated. So I like to go through that and actually give them that ammunition to talk to their managers as well.
Yeah, and I mean, I want to stay on this because we talk to a lot of people who struggle with that influencing above or needing to, they really want to implement something that seems so obvious, but then struggle. So let's say I'm armed with, $20,000 an hour. So times, here's the number of incidents or events we had this year. Where do you see people bumping into problems even when armed with that data? And what suggestions do you have to kind of get through any potential roadblocks?
I have a couple soapboxes around this, so just be warned.
Great.
The biggest one is mindset. So a lot of what my team and my goal is to change or transform mindsets from this reactive mindset into this predictive and preventive type of mindset, or even proactive. A lot of reactive mindsets, and again, I came out of the metals industry, which is still heavily reactive. There's some change, which is good, but there's still a lot of reactive mindsets, and that's because they learned how to repair their equipment by just fixing it, and then they're getting slowly better at it, which is great. So that mindset shift is really tough. I get a lot of questions around, okay, so we have this data. Can we put it on a screen so we can watch it and the operators can watch it? Vibration and torque data. I said, sure. It's not going to help them because this needs to be analyzed. It needs to be presented in such a way that it's useful. We need to look at the features that are calculated from that vibration and torque data, et cetera. So putting it in front of the operator is going to tell them, sure, this is happening from a process data standpoint, but it's not going to tell your maintenance team, here's how you should be doing maintenance in 2 weeks, or here's where your focus points should be. So really, the operators don't need to see that data, in my eyes, because that's process. They need to see the process data, not necessarily the reliability data, the maintenance data.
Okay.
So there's different types of data in my eyes.
Great. So it's really trying to think through what's the correct data to show that's going to help kind of push that through that decision or that business case effectively.
Yep. The mindset there, when I get that question, I like to point it out and just call them out, say that is still a reactive mindset. You're talking about preventive and predictive systems, but you're still trying to use them in a reactive way. And let's talk about that more and how that can change.
It's great. Let's switch gears a little bit. I want to talk about innovation. So two of the biggest things going on, let's say IoT, AI, artificial intelligence, Internet of Things. How are you seeing those tools or those concepts? I guess they're more than just tools. Where are you seeing the innovation with them? And are there others coming down the pike that you're looking at?
There's definitely others coming down the pipe. AI exists. We know that. I don't see it being directly applied very thoroughly yet in this field, in this realm. for a lot of reasons. There's definitely analysis that's enabled by technology. So I see a lot of innovation around sensor types and how to view data and how to push data to the end user. Um, what I also am a huge proponent of, though, is keeping people in that loop. So instead of just going like dark factory style, which I hear a lot about, I think it's really important to have the services of reliability, if people are using an external service, enabled by that technology. So there's a lot of pattern recognition. There's a lot of analysis that's done by those longstanding vibration analysts, as an example, that is very difficult to capture using using programs. And I don't think a lot of that's happened. I've heard about one company, I can't remember the name, I wouldn't say it anyway, but I've heard about one company that's spending a lot of time taking those analysts and trying to capture that data and essentially hard code it in to make decisions on their platform. So if they see this vibration signature, this is what it means. We have charts and, there's fields of study around vibration to help with that. But still, there's a lot of, I'll say, cross analysis. If you're looking at a whole machine, you got two different bearings and a gear set. Those things are all working together. You can't isolate just each one. And so there's a lot of that, which is still manual analysis.
Good. That's great. Great to hear. I think, the world is going to continue to change. It always has. But I do think the next couple of years will be pretty interesting. What is, I want to get one final word from you. So one final word, what's one thing about your particular expertise or from where you sit that you think other reliability engineers need to hear? Could be a reminder from the past. It could be looking ahead. We'd just love to hear one kind of final word from you, one encouragement.
Other reliability engineers, I would say, number one, torque monitoring is an underrated tool. I think it's up and coming still. I mean, I've been doing it for a decade, but I still think it's up and coming. It's not widely understood, so I think that people could do some more just kind of general research on it to understand how it's used and why. The biggest reason is why, outside of motor current torque. And then focus on the use of technology to make these reliability predictions more efficient.
Good.
There's a lot of time is used by vibration analysts in reviewing data, and there's a lot of companies out there that have great solutions to help enable those analysts. But I think that's where we're going to see a lot more innovation in the next few years in terms of making better predictions. Like I said, with the hard coding things and using AI, I think there's going to be a lot of innovation in that space.
That's good. Well, these are just great recommendations or ideas, especially, I mean, both are, but I think around torque monitoring in particular, I think that's something that I don't know if I've heard that before. So thank you for sharing that. Again, this has been Chris Barkow as our guest. Thank you so much for this conversation. We really appreciate it. He works with Regal Rexnord, where he is a reliability solutions manager. Sounds like he has a ton of knowledge. So if you need help in thinking through different tools or ways you can solve problems, I have a feeling Chris would love to talk to you. So please reach out to him. Thanks again. Again, our mission on this podcast is to help reliability engineers, really anyone, just be more successful at what they're doing by using technology and by just using practical tools that are out there. As you know, you can check out our company, reliability.com. We offer root cause analysis training, and we have a software platform called Easy RCA. If those tools are helpful for you, we'd encourage you to check those out. But as always, we just appreciate you all tuning in, as together we work towards making the world a more reliable place. So thanks, and we'll see you on the next episode.
Thank you.
Thanks, Chris.